Calculation number 2 in Chapter 1, Estimation of Critical Temperature from Empirical Correlation. Predict the critical temperature of the following hydrocarbons using the empirical correlation of NOK: normal icosane, 1-butene, and benzene. Let's do the calculation for the first component, normal icosane. The NOK correlation is given by this equation where Tc is the critical temperature in Kelvin, Sg is the specific gravity of the liquid at 60 degrees Fahrenheit relative to water at the same temperature, and Tb is the normal boiling point in Kelvin. Normal icosane is a paraffin. For paraffins, the parameters A, B, and C in the equation are given in Table 1.1. For paraffins, parameter A is 1.359397, B is 0.436843, and parameter C is 0.562244. Also, from Reed, Prousnitz, and Sherwood, the normal boiling point for normal icosane is given as 617 Kelvin, and a specific gravity is given as 0.775. With these values and the parameters A, B, and C, we can write log natural of Tc, which is the unknown that we can solve for, is equal to 1.359397 plus 0.436843 log natural of 0.775 plus 0.562244 log natural of 617. Log natural of Tc is equal to 2.87986. Tc would be equal to 758.3 Kelvin, or 905 degrees Fahrenheit. This is the critical temperature for normal icosane. For component B, 1-butene, and component C, benzene, we can perform similar calculations using appropriate values of A, B, and C and their normal boiling points and specific gravities. We can also click on Export to Excel at the bottom of Table 1.1 and do the calculations in Excel. We have now downloaded the parameters in Excel as you see here, and earlier we did the calculation for normal icosane. Let's repeat that calculation using Excel. This is the equation that we saw earlier. Also, normal boiling point for normal icosane is 617 Kelvin, as we see here. And also a specific gravity is 0.775. So we go to the cell for log of Tc and say equal A plus B times log of Sg plus C log of Tb, and we hit enter. This is the value for log of Tc that we saw earlier as 2.87986. To calculate Tc, we are gonna go to the next cell, equal 10 to the power log of Tc. This will give me the temperature as 758.33. This is the same temperature that we saw earlier. For the second component, 1-butene, we will use the parameters for alkene as you see here. A, B, C, and then for benzene, because it is aromatic, we are going to use the ABC values for benzene as you see here. Also for 1-butene, we have the normal boiling point and a specific gravity. And for benzene, we have normal boiling point and a specific gravity in these cells. So with those values, we can just copy and paste the formulas that we have for normal icosane and then paste those in the appropriate cell. As a result, we will get the critical temperature for 1-butene as 420.29, and for benzene we get it as 562.853. These are all in Kelvin.